In this video, we are going to see an example of sinusoidal steady state analysis. In this particular problem, we have asked to find out the current through the circuit, this I of t value. Now to find this one, we are going to convert this time domain circuit into phasor domain circuit. After that, we are going to solve for the current. After we find out the current in the phasor domain circuit, we are going to convert that one back into time domain circuit. Now let's go ahead and do that. Here we are going to have the new circuit. The new circuit is going to look like this, okay? And when we convert this current source in the new circuit, we are going to have this amplitude and the angle. That's going to be our current source, voltage source. Here this is voltage source, okay? So this voltage source is going to turn into 2, and this is 0 degree, but since we have sine, we have to put a negative 90. So 0 minus 90, this is going to become negative 90 degree, okay? And this resistor doesn't change. When we convert this one from time domain to phasor domain, this resistor remains the same, so we can just put 1 ohm here. But when we convert this inductor into phasor domain, this is going to turn into j omega L. In our case, omega is going to be equal to 1, because whatever the value that multiplies the t value is going to be the omega. But here we have nothing in front of t, it means it's just 1, okay? And also we know the inductance, that is 2, so 2 times 1, that's going to be just 2, so we are going to have 2j. That's going to be the impedance right here. When we convert this inductance from time domain to phasor domain, that's going to become impedance. So this is going to be our impedance right here. Now we are going to use the KVL to solve for this current, but the current we have to put capital I, but we shouldn't put time, because we are converting this one from time domain to phasor domain. In phasor domain there's no time, okay? So we are going to have this capital I. To solve this one, we are going to use the KVL. When you use the KVL, we can add this resistor, because we treat same impedance same as resistor. When you have resistor in series, you can add them together, right? So we can do the same thing here. We can add these two together. That's going to become 1 plus 2j, and that one multiplied by this current, that's going to be equivalent to this voltage source. That's going to be 2 negative 90 degree. From this one we can solve for the current. So current is going to be 2 negative 90 degree over 1 plus 2j, and if you solve for this one, the bottom is going to become 2 over square root of 1 plus 4, and tan inverse 2 over 1, okay? So this is going to become like that. Then after that, this is going to turn into 2 over square root of 5, 2 over square root of 5, and then negative 90 degree tan inverse 2, tan inverse 2. So this is our final answer. Now this one in phasor domain, we have to convert this one back into time domain. When you convert, this value is going to be the amplitude, okay? Let's put the I of t value. This first value is going to be the amplitude, and amplitude is going to be 2 over square root of 5, and then we are going to put sine. But when we put sine, if it's negative 90, it means in sine that's 0 degree, right? So we eliminate this negative 90. So when you put in sine, this is going to be, first we had to put omega t. In our case, omega is equal to 1, so this is going to be just t minus, we shouldn't put this negative 90, because when you put sine, this negative 90 will be eliminated, so you just put the tan inverse 2, right? And I forgot to put negative sign here. This is negative 90 negative tan inverse 2, so this is going to be just negative tan inverse 2, and that's going to be our final answer. I hope this helps. Thanks for watching.